viewers, in this lecture I'm going to talk about the electronic configuration and rules to find energy of the orbits. Now that's the last topic of our physics book, chapter number 2, atomic structure. Let's move to the second principle, or the second rule we can say. Now there is of-Bohr principle. Now this principle states that electron fills lower energy atomic orbitals before filling higher energy atomic ones. Now here what does that mean? Now we know that the electrons that are near to the nucleus have less energy. Now in the F-Y quantum number or F-Y principle, it states that the lower energy principles or lower energy electrons would be filled first. Like if there is valency in the K shell, it will be filled first as compared to the valency in the L, M, N, O, or what we can say is their valency. So it will be filled later. So that was the point of the F-Y principle. Now here the word F-Boy is German word that means building up. Now as we know, it means the filling. It just gives us the example of the filling. So we can simply just say that filling means building up or creating or adding. Now let me just tell you in another words the same thing. The F-Boy principle states that electrons are filled into atomic orbital increasing order like K, L, M, N, and so on. According to the F-Boy principle, the available atomic orbitals with the lowest energy are occupied before the higher energy. Just suppose if there is valency in K shell, so it will be filled first as compared to the valency in N shell. If there is valency in L shell, so it will be filled first as compared to the valency in M shell. Now that was the series. So let's move forward. That was the point of the F-Boy principle. Now there is a statement or the method that F-Boy principle just gives us, that how we can identify that which one is higher energy and which one is lower energy. So what we have to do is simply put it in a series, like one for the K shell, L, M, N, O, P, Q, R. 8 electrons or 8 shells. So put it in a proper statement or in the form of electronic configuration. Do the electronic configuration. So here what we'll find? We'll see that there is more energy in the S shell, lower energy in the S shell as compared to the 8 shell. So in this way we can identify that the lowest energy is in the first K shell. Let's move forward. So viewers, in the N plus N rule, we discussed about the energy. Now here the N is for the principal quantum number and L is for the azimuthal quantum number. Now we know that the N principal quantum numbers means of the shells, or they discuss the shells which starts from 1, K, L, M, N, O and so on. And the L starts from 0 and that 0 is for S, and then it continues like 1, 2, 3, S, P, D, F and so on. So let's discuss it with a proper definition. Now the energy of an orbital depends upon the sum of the values of the principal quantum number N and azimuthal quantum number L, as I told you. When we're gonna sum up these both, we will have the energy of the shells. Now this is called N plus N rule. According to N plus N rule, in neutral isolated atom, the lower the value of the N plus N of an orbital, or we can say that the lower the energy, the lower the shell or orbitals. Now in the condition that two different orientated electron in n plus l becomes equal. Now let's discuss this condition later. First, let me just tell you with an example. Now just suppose that there is a condition, like we have given the K shell. Just tell us the K shell and the we have the azimuthal quantum number 1 as 2. Now here we have the S shell. We can say that it's 0. Now here the energy of that would be 1 plus 0 is equal to 1. Now the energy of that orbital or shell would be 1. Now there is a condition that is given to that. In the condition when two different sum up of the electrons or sum up of the rule, when we use this rule with two different electrons, and the answer would be same. So in this condition we will see the number of the shell, like it is when it is in K shell the energy would be lesser, when it is in L shell energy would be more. So this is a condition that is given. Now let me talk about this figure. Let's see that if it is and like this 1s means it's in K shell, so it is lowest energy. If it is in N shell, or we can say that L shell, so its energy would be higher. But in both conditions the azimuthal quantum number would be 0. So this is the condition of the Fy, or we can say that n plus n rule. Now let's talk about the last rule, that is Hund's rule. Now there is a statement given to it. Every orbital in a subshell is singly occupied with one electron before any one orbital is doubly occupied and all the electron is singly occupied. Now if we have to do an configuration, like we are given these kind of configuration, like it is 1s1, then 2s2, and then 2p3. Now for that we have how many electrons? 1, 2, 3, 4, 5, 6, 7, 8. It's an oxygen. So in oxygen we have 8 electrons. Now for the configuration according to Hund's law, we will first write all electrons in the subshell in a clockwise form. Like we'll first fill this, forgot this one. First forgot this one. It's nothing. Just fill the electrons first in a proper order. Like 1, 2, 3, 4, 5. Now 8 minus 5 is equal to 3. How many electrons we left? 3. So we're gonna simply put these 3 in anti-clockwise form. As I taught you in the previous lecture or in this lecture in the previous topic, that the electrons would always be clockwise and anti-clockwise. Why? Because of the repulsive or attractive force. So that's the Hund's law, that we have to first put the clockwise order and then the remaining electrons would be considered as anti-clockwise. Now here there are two electrons which are not similar to each other. Don't take it as a similar. We'll just make it differentiate with each other, because here we have the 5 orbitals. So in this condition there are 2 electrons that are individual. And that's all about today's lecture. Thank you.